First chapter, number systems. So you have already been doing with number systems. So you know quite a lot about numbers now. So what sort of numbers have you studied in this?
Natural numbers, whole numbers, rational numbers, irrational numbers.
We studied about, you must have studied from the basic only, it always starts, no? The natural numbers, whole numbers, then integers, then rational numbers, then irrational numbers, right? Then what else do you have here? Okay. Okay, finding a rational number between two rational numbers, those type of questions you have. Then about irrational numbers, where is the place, how are the irrational numbers, where are irrational numbers placed on the number line? Okay, these type of questions we will be doing, right? So let's begin with that. Okay, I'm sharing the screen now. This was the previous day's work. Okay, I'm doing below this only. Okay. Just draw a line here. Now, the next concept is number system.
Ma'am, will you be explaining from the starting of the chapter?
Yes, I'm starting from the beginning, but I'll take the starting part quickly because you have already done this.
Yes, ma'am.
Okay, so never mind. Even if you have done, those who have missed, they can grab the opportunity. We are doing again, and it will be for those who have done also. For them, it's a revision also. Okay. So I'm doing it from the starting. So you can take down the notes also wherever you feel like. Okay. Now in this, the very first thing that you studied was natural numbers. Okay, we studied about natural numbers so many times. Then we studied about whole numbers. Okay. We did about integers, right? We did about rational numbers. In your class 8, you had rational numbers, right? First chapter. Now, here in this, now we will be doing about irrational numbers. Now, what are all these? Now, see, look here. Everyone, please look here. Don't write anything. Stop writing. I'll give you time to write. Pay attention. Rohit, what are you writing? Keep your videos on and don't write.
Ma'am, done writing.
Okay. Don't, children, please keep your videos on. Yukta, Sampath, Jitendra, keep your videos on, bache. Okay. Now see, natural numbers range from 1, 2, 3, so on till infinity. Okay, this you all know. And we represent natural numbers with the letter N. Got it? Whole numbers start from 0, 1, 2, 3, so on till infinity, and we represent it with the number, with the digit W. Integers.
Ma'am,
Yes.
negative numbers and positive numbers, and it is represented by Z.
Negative number C. What C?
Ma'am, Z. It is
Z,
represented by
Z. Yes, yes, Z. This. Okay, I thought you're saying C. Okay. Okay. So that's Z. Okay. Why do we call it Z? Because it is after a German word, Zahlen. Okay. Now, rational numbers. Since this word rational is derived from the word ratio, we call it rational. Okay. And in ratios, we have quotients. So this is represented by the letter Q. And rational numbers are numbers where you have, fraction form of a number. 1 by 5, 2 by 3, these kind of numbers, where P and Q are integers and Q is not equal to 0. Okay, this is in the form of P by Q in the ratio form, where P and Q are integers. Integers means these can be negative also, these can be zero also, these can be positive integers also. The only condition is that the denominator should not be zero. Okay, this is, you know about rational numbers, the definition of rational numbers. So we have these kind of rational numbers. Okay, then we have irrational numbers, which we represent by the letter I, capital I. Okay, now here, now you can see with a small diagram. See, we have initially we studied about natural numbers, then we had whole numbers. Whole numbers cover the whole of natural number system. Okay, then integers cover whole of the natural and whole number system, right? Then you have rational numbers, which still covers the whole of this. Okay, okay, which is in the form of P by Q, and Q is not equal to 0. And we have another set of numbers which is separate from these. These are called irrational numbers. Okay. Okay. This is all one set. Okay. Natural numbers are consisted inside whole numbers. Okay. Now, whole numbers are a part of integers. Integers are a part of rational numbers. And we have irrational numbers, which is different from rational numbers. Understood this much? Thumbs up. Great. Okay, now we say that there exist infinite rational numbers between two rational numbers. You must have heard about this. Okay. Have you heard about this? That there exist infinite number of rational numbers between two rational numbers. Heard or not? Have you heard about this? That there exist infinite
Yes, ma'am.
numbers? Yes. Okay. So how is that possible? Can anyone tell me how is that possible? How can we say that there are infinite rational numbers between two rational numbers? How is that possible? Who can tell me? Who can tell me this?
Because, ma'am, between any two rational numbers, we can divide them and we can multiply with another number. We can try different operations with them and then get so many rational numbers.
Okay. You can divide them. Okay. Now suppose if I tell you that find 5 rational numbers between 1 and 2. Will you be able to do? Please do this. Find 5 rational numbers between 1 and 2. Do it. Good evening, Harshit. Good evening, Purujit. Keep your videos on. Good evening, Pranav.
Good evening.
You're late. It's 6:20. See, you all must join on time, okay? I wait for 5 minutes, but beyond that, I do not wait. Okay? So just after 5 minutes, then I'll start the class. Okay, please find 5 rational numbers between 1 and 2 quickly. It's a small thing. How will you do that?
Ma'am, should I say?
See here. Everyone see. Those who don't know can see here. I'll show you this. Now see, this is 1, this is 2. I can write 1 as 1 by 1. I can write 2 as 2 by 1 also. Okay. If now what thing is that I want to make, can I find any two rational numbers between 1 and 2 here with the same denominator? I can. What will I do this? I will just multiply this with 10. Okay. So I get 10 by 10 here And here I get, when I multiply this, I'm trying to make the keep the denominator same and trying to find out numbers between them. Now this becomes 20 by 10. Now can I find 5 rational numbers between 10 and 20? Yes, I can. The numbers will be 11 by 10. Okay, between these two rational numbers, I am finding these numbers. 12 by 10, 13 by 10, 14 by 10, so on till 19 by 10. I have all these rational numbers here. Out of these, I can pick any 5. Okay, I can pick any 5 and that gives me my 5 rational numbers between 1 and 2. Okay, understood this much? Now, suppose if I'm asked to find more number of rational numbers, I can do one thing here. I can multiply this with 100 also. If I multiply this with 100, I will get not many numbers. This becomes 100 by 100 and this side becomes 200 by 100. Is it? So I can find not many rational numbers here also. So rational numbers that will lie between 100 by 100 and 200 by 100 will be 101 between these two. That will be 101 by 100, 102 by 100, 103 by 100, and so on. Okay, till you get 199 by 100. Right? I can have so many rational numbers in between. So this is how I can say that there are infinite number of rational numbers between two rational numbers. I multiplied with 100, I multiplied with 10, I could do with 10,000 and lakhs also. I could multiply this with 10,000 and lakhs also, isn't that? So that's the way I can find n number of rational numbers between two rational numbers. So is it possible? Now, I was saying, no, how is it possible? So this is how it's possible. Okay? So understood this much? Then let's do another sum. Okay, find 5 rational numbers between 3 by 5 and 4 by 5. Find 5 rational numbers between 3 by 5 and 4 by 5. Please, children, keep your videos on. No one's video should go off. Video on करने से पता है क्या होता है? I get a feeling that we are sitting 1 to 1. Okay? Please keep the videos on. Yes. You get the feeling as if you are in a classroom. Isn't that? Don't you get the feeling that
Yes,
you
ma'am.
are with the teacher? Okay, find 5 rational numbers between 3 by 5 and 4 by 5.
Yes, ma'am. Done.
So what will you do in this case?
Ma'am, 3 by 5 into 10 by 10 and 4 by 5 into 10 by 10.
10 by 10.
Okay, yes, you multiplied with 10. So you got 30 by, when you multiply 3 by 5 with 10.
Ma'am, 30 by 50
50.
and 40 by 50.
Yes, so that's 30 by 50. And this side you get 4 by 5 multiplied by 10 by 10. You get, see, numerator and denominator has to be multiplied by the same number. Okay, always keep this in mind. 40 by 50. So now between 40 by 50 and 30 by 50 and 40 by 50, you can have so many rational numbers between these two. So what will they be? So I can write them as 31 by 50, 32 by
Ma'am,
50.
31, 32 till 39 by 50.
Yes, so on till 39 by 50. I can have so many. One second. Huh? Okay. So you can have so many rational numbers. So out of these, you can choose any 5. Okay. Okay. So now, representing numbers on the number line. Okay, we'll do that. Now see, representing numbers on a number line is तो बड़ी छोटे बच्चों वाली बात है ना? It's a child's play, is it? You have been doing this from your childhood, isn't that? But now you are grown ups. You have come to class 9. So class 9 children should do something that is tricky, some challenging things, isn't that? Yes or no? Yes or no? Yes, you should. So we'll do that. Okay, let's do. So let's locate some irrational numbers. Now you all know how to locate rational numbers on the number line. Is that rational numbers you studied in your class 8? How do you
Yes,
locate
ma'am.
3 by 5, 4 by 5 on the number line? That you all know. Okay, we divide that much portion to that many parts, and that's how we get. Okay, and you know about integers also. Now suppose we are asked to locate some irrational numbers. So please write down, locate irrational numbers on the number line. What are irrational numbers? Non-perfect square numbers, is it?
Yes, ma'am.
And those non-perfect square numbers and those numbers which are
Cannot be
non-terminating and
represented
non-repeating. Okay?
Yes.
Non-terminating, non-repeating. उनका कोई remainder ही नहीं होता. वो चलता जाता है. Every time you get some new number in the question. So those type of numbers are called irrational numbers. So now let's locate root over 2 on number line. So you must have done this. So quickly tell me, how will you do?
Now we'll take a number line. We'll take one unit, means 1 unit, maybe 1 centimeter or 2 centimeters. Then we'll construct a 90-degree angle, and then while taking the measurement of 1 unit, we'll cut an arc on the 90-degree angle, and then join it with the 0 integer.
Yes, absolutely right. You are right, Sampath. Good. Okay. Now those who still have some doubt in that, you can pay attention. We'll do it. Now to locate root over 2 on number line, what do we do? First of all, we take the help of Pythagoras theorem. Pythagoras, सबको पता है? Hypotenuse square is equal to base square plus?
B square is equal to C square.
Yes. So perpendicular square. Okay. Hypotenuse square is equal to the base square plus the perpendicular square. Is it? This is what the Pythagoras tells us. Okay. So we take the help of Pythagoras theorem. Help of Pythagoras theorem. Okay, what help we will take? We want root over 2. Now we can write root over 2 as 1 plus 1. We can write this as 1 square plus 1 square. We can write it like this. Yes or no?
Yes, ma'am.
Yes. See, if at every step you tell me that you are understanding, then only I will move to next step. Okay. Now let's start the plotting part. Now here, what do? See, सबसे पहले तो हम number line पे सबसे पहले अपना origin ले लेते हैं. Okay, 0. We always start with 0. Now I just take numbers here 1, 2, 3. Okay, इस side भी हम एक दो numbers ले लेते हैं 1, -1, -2. Okay, now we take 1 unit here. From 0 to 1, I have taken as 1 unit. Okay, 1 unit or say 1 centimeter. All right. Now, at this point 1, where I have taken 1 unit, I will make a perpendicular here. Okay, on this line, I will make a perpendicular here. How do you make a perpendicular? कैसे बनाते हो perpendicular on a line? Studied in class 6. Practical geometry में, you take a semicircle like this, you open the compass a little, like this, take an arc, keep your pointer here, take an arc, then you join these 2 points. This is how you get a perpendicular. Yes?
Yes, ma'am.
Yes. So on this point 1, you draw a perpendicular. You take a perpendicular. Okay. So how do you take a perpendicular? You take a semicircle like this, like this, like this. Okay, from here you take an arc, from here you take an arc, you draw a perpendicular line, this, like this line. Okay, this is your 1 point, right? So you have taken a perpendicular here. Now, on this perpendicular, see, this was 1 unit. Okay, now on this perpendicular, with your compass, you will keep your pointer at 1 and you will take same 1 unit arc on this. You will cut this perpendicular at 1 unit, yani ki 1 centimeter. Okay. All right, 1 centimeter, 1 centimeter. Now, this point I have got, please pay attention, don't write anything. Okay, now you join this point with this intersected point. I name this point as, isko kuch bhi name de dete hain. This point is A. Let's call this point as B. Okay. Now OAB is a right angle triangle. Okay. Here you have got one, the base is 1 centimeter, your height is 1 centimeter, and your perpendicular that you're getting is root over 2. हो गया Pythagoras theorem से 1 square plus 1 square is equal to 1 plus 1, which is equal to 2. So your hypotenuse is what? Root over 2. So you got this hypotenuse OB as root over 2. Got it? Understood this much part?
Yes, ma'am.
Yes. Now,
Yes.
yes. Now what do you do? Now with your compass, keep your pointer at here at O, okay? And with this radius OB, take your compass and just make this circle, okay? And wherever this intersects the x-axis, this point is your root over 2, okay? Yes, I hope you have understood this.
Yes, ma'am.
Everyone? Everyone, have you all understood? See, this is important from the examination point of view also, and as your maths lab manual also. You have this activity in your lab manual also. You must be having your maths lab manual, no? You have marks for that?
Yes, ma'am.
Yes. So you have this activity there as well. Okay. If you have understood for root over 2, quickly you will understand for root over 3 also. Okay. If
Ma'am,
anyone,
I have one doubt.
yes,
Ma'am, after we place the compass on O, where do we mark the line?
after you place your compass pointer at O, take your measurement of the radius as OB and just make an arc like this, which cuts the x-axis at some point, and that point is your root over 2.
Okay, ma'am.
Okay.
Yes, ma'am.
I hope I'm clear.
Yes, ma'am.
Is this clear to everyone? Sampath, Yukta, Harshit,
Yes,
Yes,
ma'am.
ma'am.
Purujit, Jitendra?
Yes, ma'am.
Okay, anyone has any doubt, please raise your hand, you can ask. If no doubts, then I'm moving ahead. Okay. Now, similarly, on same grounds, we will do root over 3. We will find the location of root over 3 on the number line. Okay. Root over 3 on number line. Okay. Okay, now look here, for root over 3, what we need to do? For root over 3, we will take the help of root over 2. Okay. Now, again, we start with 0. We take our 0 point here. We have a 1 here. We have a 2 here. See, you have got your root over 2 at between 1 and 2. Is that? Okay. Now, this is what you have got for your value of root over 2. Now, we will start from here. Okay. Children, pay attention. Please pay attention. Stop writing. Stop writing. Now, how do we get root over 3? For this, again, we take the help of Pythagoras theorem. We can write 3 as root over 2 plus 1. We can write 3 as 2 plus 1. So 2 plus 1 further can be written as root over 2 square. 2 को हम root over 2 square लिख सकते हैं and 1 can be written as 1 square. Okay, ऐसे लिख सकते हैं ना? So for this, that means we need one line which is root over 2 and another line which is 1. Okay, so root over 2 we can already see here. Root over 2 is already here. Now on this line, this is O. You call this line O. We had taken this point as B. This was A. Now we extend this line to D. You will make a perpendicular on the line OD. Okay. Now same way as you make a line perpendicular. How do you make a perpendicular? एक perpendicular के लिए आप ऐसे एक semicircle लगाते हो छोटा सा, then an arc like this, and wherever this arc cuts, this here you get the perpendicular. This is what you do in your junior class. इसी किया था अभी थोड़ी देर पहले. You make a point here, then from here take an arc, join it. Like this you get perpendicular. So same way you have to make a perpendicular here. Okay, so when you make a perpendicular here, now keeping your pointer at point B and taking 1 centimeter distance, you will cut an arc this with your compass. Right? Now this distance is 1 unit, 1 centimeter. Now we have root over 2 here, we have 1 here. अब हमें मिल गया root over 2 and root 1, both sides we have got. Now we join these points. Now I just take this point as point E. Now I join point E with point O. E or O को मैं join कर देती. Now this becomes the hypotenuse of this right angle triangle. Understood, children, this much? Anyone who has a doubt, you can ask.
No doubts, ma'am.
No doubt,
Everyone?
ma'am. Yes, ma'am.
Everyone? No doubts?
Ma'am, do we make the arcs with the compass as well?
Yes. Yes, you have to make the arcs with the compass. Okay. How will you make arc without a compass?
Ma'am, can you once show how we make it on the compass?
Compass, how can I show here and now, which is not
Yes, ma'am.
possible. It's only possible on the notebook with the compass. You keep your pointer here. Look here. You keep your pointer, compass pointer. Pointer means the compass needle at B and cut this perpendicular like this at 1 centimeter distance. Okay. So wherever you get this point E, join this point E with the O. Okay. Join point E with point O. Right? You can try with compass, and still if you don't get, we'll practice again. Don't worry. Okay?
Yes, ma'am.
So now you can see, now you have this radius OE as your radius. From O to E is your radius. Keep your pointer, compass pointer at O and your pencil at point E and make an arc like this. Okay, which cuts this x-axis. And wherever this cuts the x-axis, that point is your root over 3. Got it? Understood, children? With OE as radius, make an arc, a big arc that cuts the x-axis at some point, and from 0 to that point is the distance root over 3. I call this point as, I give it a name, C name नहीं दिया ना कहीं भी, so we'll give it name C. All right? Is this clear to all?
Yes, clear.
Everyone? Everyone, is there anyone who has not understood this? Harshit, Purujit, Yukta, I cannot take everyone's name. You have to come forward and tell me, ma'am, I haven't understood this. Okay, although I'm trying to take everyone's name, I'm making an effort that I don't miss anyone,
Ma'am,
but still you have to come up.
ma'am, and in exams, we have to mention the unit measurement which we are taking.
Yes, you have to, beta. You have to take a unit measurement. Unit measurement means you take 1 centimeter measurement, right? Okay. Take 1 centimeter measurement.
Okay, ma'am.
Okay, so now we did for root over 3, we did for root over 2, we did for root over 3. Similarly, you can try for root over 5 also. And suppose if you are given root over x, if you are given something like कोई भी number आपको दिया randomly from anywhere, root over 5.3, root over anything. Okay, so how will you find that root over x, locate root over x on the number line? Do you think you will make अभी आपने ये एक perpendicular triangle दिया था, right angle triangle, then you took this right angle, and then you will make over this another right angle triangle. How many will you make? है ना? Finally, it's going to end up like this, like this. So, what is the general thing that you, if you are given any number to find the locate its location on the number line, how will you do that? Okay, so we'll work on it. Locate root over x. Represent, not locate, represent. Okay, represent root over x on number line geometrically, right? Okay. Now for this you need to know some steps. Okay. What are the steps? You will be writing the steps now. Please write this. Represent root over x on the number line. Steps. Steps of construction. Please write the steps. What do you have to do? Whenever you are doing something geometrically, you always write the steps of construction. Even for root over 3 and root over 3, you can write steps of construction. Okay, the very first thing that you do is draw a line of length x, not root over x, length x. Suppose if this x is given to you some number, you have to make a line of that much length. Okay, draw.
Ma'am, so what is the value under the root in place of x? That much measurement.
Yes, that much length. Okay.
Okay, ma'am. Okay.
Draw a line of length x, right? See, but very specifically, I have written length x, not root over x. X. Whatever is written under the root, that value of length. Okay. Now your second point will be, okay, so we drew a line, we will do the construction. Now you write the second point. Now your second point is extend the line. Now this line x, extend the line x by 1 unit. 1 unit means 1 centimeter. Okay, unit can be actually anything, but for now you just take 1 centimeter. Okay, extend the line x by 1 unit. 1 unit I am writing here, 1 centimeter. Right? Okay. Then your third step will be take the midpoint of, this is A. I'm writing here, this is B. AB is taken to be. Now see here, children, before writing the third step, I'm taking AB as line X. Okay. This, draw a line of length X. So this is X centimeters. A to B is X centimeters. Then what? Extend the line X by 1 unit. Yani ki 1 centimeter. Now I have extended this line by 1 centimeter. Okay. This much. Understood? Okay. Now, your third step is midpoint of AC. Now, A to C line, midpoint of this A to C, not A to B, A to C. This complete A to C line is now x plus 1 centimeters. Is it? A
Yes,
to
ma'am.
C line is x plus 1 centimeter, okay? Now you take the midpoint of AC, then you draw a semicircle. Draw a semicircle over it. Okay, semicircle with center O. Now suppose if I'm taking the center of AC as O. Okay, I take the midpoint of AC as O. Okay, this point is sorry. This point is O. I take the midpoint of AC. Now with this midpoint from O to A as a radius, I draw a semicircle like this. Okay. Okay, taking OA as the radius. OA and OC is the radius now. I draw a semicircle over it. Got it? Understood this much? Children, understood this much?
Yes, ma'am.
Okay.
Yes, ma'am.
Now, you will take your scale and you will join this point B straight with this semicircle. Straight like this. Okay? With D. Just take your scale and join it perpendicular. And if you do not know how to draw a perpendicular, then you can take like this. Take a perpendicular distance, draw it like this. Okay? Draw it straight on the semicircle so that it meets the semicircle at point D. Right? Understood this much?
Yes,
Understood
ma'am.
this much? Now this distance B to D, this distance B to D is your root over X. Okay? Now how do you say that this is root over X? How will you prove it? For that we will do one more sum. Okay, this distance is your root over X. All right?
Okay.
Yes, whatever measurement you are given, okay? Either this your X is 5.3 or 6.7 or 4.2 or 7.9, whatever it is given. Okay, so this is your root over all this. Root over whatever X you are given, this much distance is your root over X. This is a general method for every number, whichever number you are given. This is how you need to find it. Okay, and now our next step is to prove it. How do you say that this is your root over X? Okay, how do you say that? For that, we will do one more sum, but before that, your time is coming close by. Your class time is over, children. Hello?
Yes, ma'am.
So today, class time is over. We have class tomorrow also, right?
Yes, ma'am.
Yes,
So
ma'am.
beyond this, we will do how to prove that root over X is that actual number. So we will do some more sums on that. With that, you will get to know that this is your actually root over X. Okay?
Okay.
Ending the class now. I hope today's class was helpful to you. Helpful and interesting to you? Say yes or no.
Yes, ma'am. It was very
Yes, ma'am.
interesting. This topic is very interesting.
Yes, who's that?
Ma'am, will this question come for 5 markers?
Yes. Come for good marks. Maybe four marks.
Ma'am, but what if it's square root 2?
If it is square root 2, then we have already done here.
Ma'am, then will that be for 2 marks?
Yeah, that will come for, that won't be for 4 marks and all, but still it will carry good marks. 3 to 4 marks it will carry.
Yes,
Okay.
ma'am.
Construction questions do carry higher marks, greater number.
Yes,
Okay.
ma'am.
So I hope this was interesting to you, helpful.
Yes, ma'am.
Some
Yes, ma'am.
use, It has made some difference what you knew earlier to now what you have learned.
Yes, ma'am.
Okay. So thank you for today, children. We'll continue tomorrow. Bye bye.
Thank you, ma'am. Yeah, ma'am.
Bye, beta.